Okay, let's pick up where we left off last time and look at finding the present value of a lump sum. So in this case, we're going to start with looking at the formula approach and then quickly move to Excel and the time value calculator approach, which are the preferred methods. In fact, the calculator will be the one that we're going to be using the most. Let's first look at this formula up here. If we're finding the present value of a lump sum, we're going to get the cash flow denoted again here with L. Like I mentioned in the last video, that could be a C or a PV, sorry, an FV in this case, a future value amount. But there's some amount we're going to receive in the future, some value, and we're going to divide that by 1 plus the interest rate raised to the nth power. So another way of representing that is multiplying that number times 1 over 1 plus r to the nth power. Again, where r is the periodic discount rate, so that could either be an annual rate, a monthly rate, a daily rate, etc. And then n, the exponent n is the number of periods. Again, whether that's the number of years, the number of months, the number of days, etc. So we need to adjust both the periodic rate and the number of periods to be the same periodicity. If we're talking about months, they both need to be months. A monthly rate and the number of months. If it's daily, we need to have the number of days and the daily rate, etc. So let's look at a present value problem. What is the present value of $5,000 received 3 years from now if the required rate of return is 8.25%? So our lump sum is $5,000, and then we're going to divide that by 1 plus the interest rate, 1 plus the R, which in this case is 8.25%, and then raise that to the number of periods. In this case, everything is years, so I'll raise that to the third power. We do that calculation, we get 39.41 and 73 cents. In the second example, if we changed the periods to months and tweaked our question just a tad and said the required rate of return is now 12%, that would be an annual rate. And if we discount that monthly, we would get a monthly rate. So 12% divided by 12 is obviously going to be 1% per month. So in this case, we're going to take $5,000 and divide it by 1 plus the periodic rate, so 1.01, and then raise that number to the nth power, the number of periods power. So in this case, 5 years times 12 months per year is going to be 60. So we raise 1.01 to the 60th power, divide 5,000 by that number, and we would get a present value of $2,752.25. Let's look at how we would do that with Excel. Here are the inputs that we would use to figure out the present value. The first input's the periodic rate, then the number of periods, the periodic payment, and then a lump sum, and the type are both optional arguments, just as with the future value calculation or the future value function. So in this particular case, we're going to enter in 8.25% or 0.0825. And then 3 is the number of periods, 0 is the periodic payment, $5,000 is the lump sum. And if we stick that into Excel, we would get an answer of $3,941.73. Note that there would be a negative sign in Excel. That would be the output. So the proper interpretation would be, it would take us depositing $3,941.73 and then earning 8.25% over a 3-year horizon to end up with a future value of $5,000. Alternatively, with that second example, we can adjust things for monthly periods and monthly rates by taking the 12% interest rate, divide that by 12 to get a monthly rate. We would have 5 times 12 to be the number of months in our calculation. There are no monthly payments, and then again our future value, our lump sum at the end of this is $5,000. So we stick that into Excel, get an answer of $2,752.25, again with a negative sign to denote that that's how much we would need to deposit or invest in order to turn that into $5,000. So let's go ahead and just go to Excel and take a look at these calculations in action. So here we're starting with a future value of $5,000. Our number of periods in the first example was 3 years. Our interest rate per year is 8.25%, so 8.25%. No periodic payments, and so we can go up here and we solve for the present value. We type in equals BB and then the parentheses, and it tells us what we need to insert into these arguments. So the first thing is the rate. I'll click on rate, hit comma, move to the number of periods. Again, hit comma, touch on the cell that has the payment input, and then lastly the future value. I'm going to ignore the type this time. Again, Excel defaults to an end of period cash flow, and so I do this and I get an answer of $3,941.70. Oh goodness, it says 72. Maybe I had a misrounding of a penny earlier. Anyway, we're very close, and everything is working fine. Let's just tweak that to change it to a monthly rate and the number of months. So if we had 5 years and we're looking at the number of months, we'd have 5 times 12. If we had a 12% interest rate, we would need to enter in 0.12 and again divide that by 12 to get a monthly periodic rate. And we would come up with the answer that we had before, $2,752.25. Let's look at how we would do that with a calculator. So I'm going to, oh, by the way, and this is a good practice, is to clear out your previous work. So I'm going to hit the second key and then clear work down here. And that should, oh wait, and then second, and then clear time value of money. That's going to clear everything in the calculator, so we're kind of starting from scratch. One of the common problems with the calculators is that you can have an old input in there, and it can throw off your calculations if you're not very careful about clearing out things or re-inputting things. So let's put in the stuff that we need here. 3 is the number of periods for that first example. 8.25% is our interest rate. $5,000 is the future value. There are no payments along the way, and so we want to compute the present value, and we would get $3,941.72. Now I'll show you how you can just type over some things. In this case, if we want 5 years, as in the second example, at 12 months per year, we would have 60 months. I can hit the N, and it's going to put that over what was previously there. The interest rate is going to be 12%. Again, I'm going to divide that by 12 to get a monthly rate of 1%. Hit that, or input that into the interest rate key. And here's something I can do to just check what my other inputs are. I can hit this recall button, recall future value, and that tells me what's been input there. So, oh, this is still good. 5,000 is still a future value, so I can leave that alone. Let me just double check what the payments are. They are still 0, so everything is fine there. I want to, again, compute the present value, and I get $2,752.25 as my answer. So everything is working just as it should with the calculator and with Excel compared to those formulas, the longhand formulas. So this, the calculator or the Excel is going to be the preferred approach depending on what you have available for your tests and for working class. So let's go ahead and stop here, and we'll pick up in the next video with finding the present value of a series of lump sum payments. So several different payments of different sizes, or perhaps even the same amount. So we'll look at that present value of a series of lump sums in the next video. So I'll see you then.
We get it almost every night, and when that moon gets big and bright, it's a supernatural delight. Everybody was dancing in the moonlight. And everybody here is out of sight. They don't bark and they don't bite. They keep things loose, they keep things light. Everybody was dancing in the moonlight, dancing in the moonlight. Everybody feeling warm and bright. It's such a fine and natural sight. Everybody's dancing in the moonlight. We like our fun, we never fight. You can't dance and stay up